So in continuation to previous class of set theory, we have seen the types of sets and the operations on sets. Next part, what is that we are going to see is the number of elements. Number of elements in A union B, A intersection B, only in A or only in B, that is related to N of A union B, denoted by N of A union B. So how do we proceed with that? Let us check it out. Let me share my screen. Please, anyone, do you confirm? Do you confirm where did we stop in the previous class?
So we did this.
Yeah, we did this and even this also, no?
Yes, sir.
And this also we finished, I think.
Yes, sir. Yes, sir.
Now this is what we're going to see now. N of A union B. N stands for number. Number of elements in A union B. A or B. It's nothing but number of elements of A plus number of elements of B minus number of elements of A intersection B. Why is it so? This is very simple. I already explained it. That is, if you take a set A, this is set A, and if you take another set B, then if you want the number of elements in A union B stands for either A or B or both. Either A or B or both. So this is B. I have not named it. That is B, and this is A. Let me say this is A. Then N of A union B means N of A plus N of B. If you write, what happens then? That A intersection B will be repeated. Repeats twice then. That is the reason why we subtract this area. Which area I'm talking about? I'm talking about this one. This part, wherever the intersection of both is happening, that's what I'm talking about. Wherever the intersection of both is happening is nothing but A intersection B. From the name itself, we can understand intersection. Intersection means common. Wherever the common area is there, therever the intersection happens of horizontal and vertical lines. So because it is added twice, we subtract it once. So that N of A union B is equal to N of A plus N of B minus N of A intersection B is quite understandable. And the next one is whenever A and B are disjoint sets. A and B are disjoint set, that means nothing is common to both. Then in that case, it will be like this. Disjoint means you can have the sets like this. This is one set A, let me say. This is another set B, let me say. And nothing is common to both. And in that case, you can straight away add them. That's what is given. So whenever disjoint sets are there, no need of minus N of A intersection B. Even if you write also A intersection B is a null set. The number of elements in null set is 0, and hence this part becomes 0. Similarly, N of A minus B, only A but not B. That means N of A minus N of A intersection B. Similarly, N of A minus B plus N of A intersection B is equal to N of A. This is N of A means only black lines area, only vertical lines area, N of A. Means N of A totally minus N of A intersection B. Similarly, N of A delta B is number of elements which belong to exactly one of A or B, one of A or B. That is N of A minus B union B minus A minus B union B minus A. So this is N of A minus B plus N of B minus A, because I said already, I explained it, symmetric difference. Symmetric difference is nothing but A minus B union B minus A. What is that? What does it mean? Only A plus only B is nothing but symmetric difference A delta B. In this one, nothing is common, and hence that union becomes plus directly. Union becomes plus directly, or otherwise you can mention it in this way also, N of A minus N of A intersection B plus N of B minus N of A intersection B. This way also you can represent, which is nothing but N of A plus N of B minus twice N of A intersection B. Similarly, N of A union B union C, when three sets are there, N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. And this also I explained by taking three sets. By taking three sets, I already explained it. Let me show you that again. That is, if you take a universal set U, and this is one set A, and this is another set B, and this is another set C, then you have to understand that there is a common area for all this. There is a common area for all this. That common area is nothing but common area for all the three is nothing but this. This is the common area. Now, if you want A union, B union, C, this is what I'm saying, this as A, this as B, this as C, please. So, this is, you have to understand that this is N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C. That means whenever you are subtracting A intersection B once, and this part will also be subtracted. And whenever you are subtracting N of B intersection C, again this part will be subtracted. Already subtracted, again it will be subtracted. When you are subtracting N of A intersection C, this is again subtracted. So it is three times it is subtracted, but that is the reason why we write plus N of A intersection B intersection C. Remember this, N of A union B union C is equal to N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. Similarly, number of elements in exactly two of the sets, only two sets, A and B, B and C, C and A and B, B and C, and C and A. Then you have to subtract this in this way, N of A intersection plus N of B intersection C plus N of C intersection A minus 3 N of A intersection B intersection C. How do you understand this? See, what is the meaning of A intersection B? This is A intersection B. But what is that he needs? Exactly two of the sets. But here, what is that happening? This part includes C also. Which part? I'll change the color and show you. Which part includes? This part is included. So, what is that you have to understand? What is that you have to understand? That part is included, and this one. This one is included in A intersection B, B intersection C, and C intersection A. And hence, if these three are added, what happens? It is subtracted how many times? Three times it is to be subtracted, because it is common. But we need only A and B, B and C, or C and A. And hence, this is repeated three times. That is why it is subtracted three times. And similarly, number of elements in exactly one of the sets ABC is equal to N of A plus N of B plus N of C minus twice N of A intersection B minus twice N of B intersection C minus twice N of A intersection C plus thrice N of A intersection B intersection C. If you see that carefully, exactly one of the sets. Exactly one of the sets. What does it mean by one of the sets? Anyone, do you respond, please? What is the meaning of exact?
Only B or only C.
That's right. So only A or only B or only C. So if I write n of A plus n of B plus n of C, what happens is n of A plus n of B plus n of C. If I write that in n of A, B comes and C also comes. B comes and C also comes. How many times it comes? So when you write n of A, no, n of A includes this common area and C and A common area also. So from n of A, you have to subtract n of B intersection C minus n of A intersection C. Similarly, from n of B also, it is to be subtracted like that. So what happens? It will be subtracted twice n of A intersection B minus twice n of B intersection C minus twice n of A intersection C plus thrice n of A intersection B intersection C. This is what you have to understand. It is all common sense, please. Through the Venn diagrams, you can understand that, and you follow the problems also. Then, if at all any doubt comes, we will discuss there also. N of A, N of A complement union B complement. What does it mean? N of A complement union B complement is nothing but N of A intersection B whole complement. Let me explain you the meaning of it. Let me explain you the meaning of it. See, this is A, let me say. And let me say this is B. What is the meaning of N of A complement union B complement? What is the meaning of A complement first? What is the meaning of A complement first? Not A. I'm saying that green one as A. Then N of A complement means not A. Not A. A should not be there. Not A. This is not A. Not A, please. A should not be there. This is, you have to understand A complement, and then next what he's saying is, anyone, what is the second part of it here? B complement. Let me write it. Let me write it. This is A, please. This is B. What is the meaning of B complement? Let me change the color. What is the meaning of B complement? Anyone, please?
Other than
Not B.
Not B. Not B means you will have like this. Not B. It goes like this. Check it out. Yeah. Not B, please. This is not B. This is what not B, please. Now, A complement union B complement means A complement is black lines, that is horizontal lines. Union B complement means vertical green lines. Union means either black or green or both. I repeat, what is the meaning of A complement union B complement? Anyone, please? Either A complement, its meaning I'm telling you. Either A complement or B complement or both. So I can observe that this white area is not included in that one. This white area is not included in that one. That is the reason why we subtracted from the total universal set. That's what he did. N of U minus N of A intersection B. Are you there, every one of you? Please respond. respond. I have drawn the diagram. Yes, Rich. This is union. That is, I'm sorry, universal set. This universal set minus n of A intersection B. That's what it is. So n of, whenever you get this P of n of A complement union B complement is equal to n of A intersection B whole complement. N of A intersection B whole complement. A intersection B whole complement means not A intersection B. Not A intersection B. Rest all the area. Next, that is equal to n of U minus n of A intersection B. Similarly, n of A complement intersection B complement. N of A complement intersection B complement is nothing but just the reverse of this. Everything will be reversed. Reverse means union becomes intersection, intersection becomes union. This of course remains the same. This will be reversed. But what is the meaning of it? Neither A nor B. A complement intersection B complement means neither A nor B. Neither A nor B means it is total minus A union B. That means whatever the circular area is there, inclusive of both, circular area is to be subtracted to have neither A nor B. That's what he did. Neither A nor B means A and B area is totally subtracted from the universal set. Okay. Now, if anyone wants to take the screenshot of it, you can take it. Let me move to the next part of it. Yes. Now see the question, please. N of U given, N of A given, N of B given, N of A intersection B given is equal to 100. N of A complement intersection B complement is needed. But it is all common sense here. You have to understand it with more common sense. Don't try to see them always in the form of the formula, but try to understand them in the real-time application. A complement intersection B complement. What does it mean? Neither A nor B. Neither A nor B. I can write the formula, but I'm showing it to you how that formula comes. That's what I discussed in the previous page. Whatever I discussed, that's what I'm explaining it now through the diagram. You will be understanding in a better way. That is, this is A and this is B. Now what it needs is A complement intersection B complement. Intersection means common area. Intersection means common area, not A, not B, not A, not B. How it goes? This is A, this is B. Not A means outside A. Outside A. What is outside A here? This entire thing is outside A. I'm drawing it excluding A. Excluding A. Yeah. Check it out, please. Understand it. Done. This is excluding A. Now excluding B is nothing but B complement vertical lines. I am showing it in vertical lines like this. So what is that he needs there? He needs the intersection. This is more comfortable, yeah. Why is it more comfortable, you know? Intersection means wherever both the lines are intersecting is the required area. Wherever both the lines means horizontal lines and vertical lines are intersecting, that is the required area. So where it is not intersecting, that we don't need. So that's the reason why you can check it out that A union B do not have The intersecting lines, just check it out. So we need only the intersection part here. Intersection part is outside of A and B, totally. So what is that? You have to understand N of A complement intersection B complement is nothing but N of U means total minus N of A union B. This is what you have to understand. So by now you know the formula for N of A union B. Everyone knows it. What I feel. You respond. Come on, expand me. N of A union B, please. N of A plus N of B minus N of A intersection B. That's it. Now subtract 700 minus 200 minus 300 plus 100. This should be your answer. How much is it, please?
300.
That's it. That is a method you have to understand. I have drawn the diagram for you to understand in a better way. Neither A nor B. Neither A nor B. So from the total, you have to subtract. I think it's clear. Going to the next one. In a city, 20% of population travels by car. In a city, 20% of population travels by car. N of C, 20 by 100. 50% travels by bus. N of B, 50 by 100. And 10% travels by both. How do we write it symbolically, please? Both?
N of C intersection B.
It's nothing but
10 by.
therefore, the persons traveling by car or bus, R over R stands for union. N of C union B is equal to N of C plus N of B minus N of C intersection B. What is N of C is 20 by 100. What is N of B? 50 by 100. What is N of C intersection B? 10 by 100. So the answer is 20 plus 50 minus 10 by 100. 100 is common to all the denominators. That is why I have taken it as LCM 70 minus 10, 60 by 100. 60% population, they travel by both. 60% population, they travel by both. That's it. Hope you understand it, every one of you. Please respond.
Yes, sir.
Yes, sir.
शाश्वत है क्लास में?
Yes, sir.
मिलोनी,
Yes, sir.
अलेसा,
Yes, sir.
yeah. Next. Let me write that. Next question, I am erasing it. If anyone wants to take the screenshot, you can take it. I am removing it now. Done. In a class of 55 students, the number of students studying different subjects are 23 in mathematics. Let me write the data. N of M, 23. N of P, 24. N of P 24. Okay. Anyone do help me out in writing the data?
So N
N of C, chemistry. It's not visible. 90.
yes, sir. 90.
12 in math and physics. Data is very clear.
N of intersection P.
Next.
N of M intersection C.
P, no? M intersections. Is how much?
9.
N of
P intersection C.
is how much given? 7, huh?
7.
Now N of
M intersection P intersection C. 4.
So what is that we need here? What is that we need? The number of students who have taken exactly one subject. The number of students who have taken exactly one subject. That means, what is that we need? Just understand the notations, please. Enough. He must take only M, intersection, P, complement, intersection, C, complement is needed. Similarly, N of M, complement, intersection, P, intersection, C, complement. Question mark. Yes. Third one I'm not going to write, you have to tell me. Comfortably sleeping, everyone in the class?
M intersection C intersection P intersection C.
M intersection, M complement intersection, P complement.
Intersection C.
These are all we need. These are all we need. Let me show you the diagram so that it is easily understandable and you can also do that easily. This is universal set, which consists of, I think, in a class of 55 students, he's saying. This is one set. And this one is another set. And this one is the third set. Just observe that. Now I need exactly one subject, please. Exactly one subject. Subjects there are, this is M, this is P, this is C. There is some area common to both M and P. There is some area common to both M and C. There is some common area for all the three also.
M is 2.
I don't think so.
So because M intersection.
Let me complete, and after I'll come to you. Just a moment, Rania. Just a moment.
Yes, sir.
So this is now I'm finding the first one. First one, please. First one, N of M intersection P complement intersection C complement. It is all common sense that n of m minus, come on, tell me that. N of m only m is needed. हमको only, we need only this part. Only this part. But if you write n of m, you know what happens? The entire thing comes here, and this is there, and this is also there. This is to be subtracted. Come on, tell me.
Minus n of p intersection m.
That's good. And also,
Answer minus n of p intersection m.
M intersection with C.
yeah. But by that one, it is subtracted twice, and hence it is to be added. Added once. Because we subtracted twice. When this is subtracted, this is already subtracted. The common area for 3, for all the 3. When you subtract m intersections here also, it is subtracted. So twice it is subtracted and hence added once. This is what I'm talking about. Common area of the 3 colors. Come on, substitute. Tell me the value, please. N of m is 23. Minus n of p intersection m is 12. Minus n of c intersection m is 9. Plus n of m intersection p intersections is 4. So it is 27. Minus 21. It should be 6. Ananya,
हाँ सर वो मैंने
you might have mistaken it the last part. I'm telling
हाँ
you.
सर
Definitely you must have mistaken at the last part. Correct or not me?
yes sir
वो मतलब उसके बारे में सोचते नहीं generally लोग, but it is to be thought when you are subtracting particular area, then it is subtracted twice. In that case, you have to add it once. You have to add it once. Similarly, can you try it out for the second one? You tell me the value. I'll be writing that. For the next one, that is, I'm talking about yellow color. Yes, Milon is saying something.
Sir, the answer is 9 for P and 7 for C.
Very good. It is 24 minus M intersection P, 12 minus P intersection C, 7 plus 4. So it is 9. So that is also right. Coming to the last one, I'm writing it in green color. Green color. NFC. What is NFC? We are writing 19 minus. Come on, tell me common area of M and C, please. Common area of M and C is 9. Common area of B and C is 7. And common area of all plus 9. So what is it? 23. 23 minus 16, please. 23 minus 16. 7, huh? बस अभी खाना खाया होगा, सब लोग आराम से सो रहे हैं. 6, 9, and it is 7. And hence it is all of this. Okay. The number of students who have taken exactly one subject is saying, unlike this, the total number of students who have taken exactly one subject differs again. If before this number, if it is given that the total number is given, then what should be the answer? Anyone, please?
It's not given in B.
sir, 9 plus 7 plus 6,
You're right.
22.
Miloni, what I'm saying, it may be asked like that. I'm saying. हाँ बेटा, मैं ऐसा भी दे सकता है बोल रहा हूँ बेटा. तो मतलब 9 प्लस नहीं 6 प्लस 9 प्लस 7,
Yes, sir.
adding those 3, that is 22. So 22 students have taken only one subject. Ananya,
Yes, sir.
understand, no?
Yes, sir.
Every one of you, please.
Sir,
बोलो ऋषिकेश.
सर मेरे को वो समझा कि n of m only, तो उसका वो फॉर्मूला समझा सर, पर वो ऊपर n of m इंटरसेक्शन p कॉम्प्लीमेंट इंटरसेक्शन c कॉम्प्लीमेंट ये ढूंढना है, ये कैसे आया सर? मुझे नीचे का फॉर्मूला समझा कि सर कैसे आया m only पार्ट.
तो क्या समझा नहीं बता.
वो n of मतलब n of m only is equal to n of m intersection p complement intersection c complement.
p complement का मीनिंग क्या है बेटा?
Not p,
c complement का
not c,
intersection का
common part,
and you either intersection का
common part.
common part. So not p, not c, m, only m, only m, m and not p, not c.
अच्छा,
इसको पढ़ना ऐसा चाहिए, ऐसा पढ़ना चाहिए. M and not P, not C, like that.
अच्छा, yes sir,
Okay.
yes sir, okay. Thank you.
बाकी लोगों को बुलाएंगे एक बार. शाश्वत है क्लास में? प्रसाद. प्रसाद ने बहुत अच्छा प्रोफाइल पिक लगाया, कभी बुलाया तो बात भी नहीं करता यार. राहुल. सोहम.
Yes, sir. Yes, sir.
ओके बेटा. श्रेया, सोमया,
Yes, sir.
दिव्या,
Yes, sir.
वृषिल, निशिल. और आज के जमाने में लड़कियां ही अच्छा हो गया यार. कोई भी लड़की को बुलाओ, लड़की हाँ बोलेगी. लेकिन ये लड़कों ने बिल्कुल क्लास में ही नहीं है. ये लोग कहाँ पे गए? मीट इज देयर? मीट. ध्रुव, रचित.
Yes sir.
Are you understanding this?
Yes sir.
ऋषभ,
Yes sir.
नेहा,
Yes, sir.
वेदांत,
Yes sir.
दर्शन,
Yes sir.
सब लोग समझ गए ना बेटा? मथुरा,
Yes sir.
Yes, sir.
हंस रही है लड़की. क्या हो बेटा? तेजस. हाँ बोलो, बोलो रे मधुरा.
किसी लड़के ने मेरे नाम पे ये सर बोला था पहले.
अच्छा 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 अच्छा. तेरा नाम उसका नाम सेम है क्या रे? मधुर होना चाहिए रे. मधुरा ही तो लड़की होता है ना, है कि नहीं?
यस सर.
अपर्णा राणे
Yes, sir.
आ रही है रोज क्लास में?
हाँ सर.
तनीषा,
Yes, sir.
निर्जरा,
Yes, sir.
मेहुल, ठीक है, मिटा दिया. We'll go to the next part of it. It is The laws of algebra of sets. Simple to understand. Don't see them as formulae. Just try to understand them in a most common way, in the most logical way. A union A is nothing but A. A or A is nothing but A. A intersection A is nothing but A. Correct or not?
Yes, sir.
Yes, sir.
Common of A and A is A. A union phi. Phi is a null set. Is A. A intersection U. Universal set. Common area of A and U is nothing but A only. This is U. And this is A. Common area of this U and A. This is U. This is A. Common area of both is nothing but A only. This one only. That's what he's saying. That's why I'm telling you, understand them with a most common sense. What I mean to say by most, I don't know, but understand them with common sense. That's it. Okay, next is if that is phi and u are identity elements for union and intersection respectively. What does it mean by identity elements? If you add 0 to 2 or if you add 2 to 0, you will get identical element. This is called 2 is the identical element. So 0 is said to be additive identity. 0 is said to be additive identity in the real number system. Similarly, whatever is added, if you get the same, that means A union A, again you are getting A intersection A, again you are getting A union phi, again you are getting A intersection U, again you are getting A. That is the reason why phi and U, this one, phi and U are said to be the identity elements because they give again A only. They give again A only. That's what you have to understand. Next is commutative law. Commutative, everyone knows A union B is equal to B union A. A intersection B is equal to B intersection A. A delta B is equal to B delta A. Who is telling me what is A delta A, A delta B? Respond.
Sir, can
I asked you A delta B, please.
the symmetrical difference between A and B?
So what does it mean?
A minus B union B minus A.
Correct. That means we don't want intersection here. Only A, only B. That is nothing but symmetric difference. So whether you find out A delta B or B delta A, that makes no difference. That makes no difference. So this is also commutative. Commutative law means you can make left right and right left. Okay. Next, A minus B. Of course not equal to B minus A because the next one I'm talking about the next one, A minus B not equal to B minus A. What does it mean? Only A and it is only B. How they are equal? They are not equal. Similarly, A cross B is not equal to B cross A, which is known to be Cartesian product. You will be getting that. Next part is Cartesian product, but here by mistake, it is given here itself. Anyway, you will see that. That's very simple also. Difference and Cartesian product. Difference and Cartesian product of two sets are not commutative. That means they are not equal. If they are not equal, we say that they are non-commutative. Similarly, associative laws. Associative laws means A, B, C are any three sets, then A union, B union, C is equal to A union or B union C. The bracket may change. That makes no difference. Similarly, A intersection B intersection C is equal to A intersection B intersection C. A delta B delta C is equal to A delta B delta C. That means that brackets can be varied, no problem at all. So they follow associative law. What is that? What does it mean by associative law? The addition of real numbers follows associative law. What does it mean? 1 plus of 2 plus 3 is equal to 1 plus 2 plus 3. This is nothing but the associative law over addition. Even multiplication also, you can follow the same. 1 into 2 into 3 is equal to 1 into 2 into 3. Okay. Are you there? Every one of you, please respond.
Yeah, there, sir.
So next one is the union, intersection, symmetric difference of two sets are associative. That's what it is, associative. And this is not associative. This is not associative. Subtraction here, a minus b minus c is not equal to a minus of b minus c. It's obvious. Whatever the rules we follow for real number system, it is value is 1, no 2, no.
Yes, sir.
What is its value? 2. And if you write it as 1 minus 2 minus 3, what is its value? Minus 4. Both are not equal. Both are not equal. The same is followed even in the set theory also. Nothing more to remember or understand there. This is just follows the real number system, not associative. These are not associative. That is what Cartesian product he said. That is what we are going to see next. It is also very simple. We'll move to the next one. Distributive law.
So can you go to the previous slide?
What do you say, Milani?
So can you go to previous slide for a minute?
Yeah, just a moment. Yeah.
Thank you, sir.
And I think it is very much given in your study material also, if you refer to. If you take the screenshot, that will be okay, because I'll be taking only the required portion of the study material, required portion to the student. That will be better. Now, distributive law. Distribution. I need not have to explain you that. For example, if you see the distribution over multiplication, A is to be distributed to B and as well to C. This is called left distributive law. Similarly, if you want to see right distributive law, it is AC distributed to A and C distributed to B, and it is AC plus BC. It is said to be right distributive law. This is said to be left distributive law. That's what it is. I need not have to explain you. Similarly, in the case of the sets also, it will be same. In the case of sets also, it will be same. Like A union of B intersection C, distribute A to B, and whatever the symbol is there, use it same. Intersection A union C. Like what? For example, it is 1 into 2 plus 3. What is that we write? 1 into 2 plus 1 into 3. That's it. That's what it is. No need to remember them separately. No need to remember them separately. This is A is distributed. This is called left distribution. And this is called right distribution, not given here. Right distribution is also there. We can follow the same. Similarly, if you see A intersection of B union C is equal to A intersection B union A intersection. This is also distributed. Here you have union. Here you have union. Here you have intersection, please. Okay. So now union and intersection are distributed over intersection and union respectively. A cross of B intersection C is equal to A cross B intersection A cross C. This is also following distributive law, and cross we will be seeing in the next part of it. De Morgan's law. This name is frequently used in set theory. De Morgan's law. What does it mean? A union B whole complement is equal to A complement intersection B complement. If I draw the diagram of one of them, then you can easily understand the rest. See, I'm drawing the diagram here. Let me take one circle. I have taken one circle here. Let me take another circle of green color. I have taken, and it is B, let me say, and let me say this as A. Now, what is that needed here? A union B whole complement. Anyone, do you help me out in telling, writing this, in shading this region of A union B whole complement? Anyone in the class?
Sir, excluding the circular region.
हाँ ऋषिकेश क्या बोला?
Excluding the circular region.
That's all. That's all, please, my dear boys and girls. We need only the area which is outside A and B, which is outside A and B. That's it. And hence, A complement intersection B complement, A complement union B complement, A complement union B complement. The formula is there. De Morgan's last first formula. De Morgan's last first formula is that A union B whole complement is equal to A complement intersection B complement. A complement means outside A, B complement means outside B, and दोनों का intersection लिया तो हमको ये निकल जाएगा. So remember this. This will be used not only here. I'm saying in probability also you'll be getting like this: P of A union B whole complement is equal to P of A complement intersection B complement. You'll have to write like this, that N is replaced with P in probability. So if you have better understanding here, those problems you can solve very easily. So number one of De Morgan's laws. Number one of De Morgan's laws is that A union B whole complement is equal to A complement intersection B complement, and it is vice versa. You can understand this easily. A intersection B whole complement. What does it mean by A intersection whole complement? Anyone, please? A intersection B whole complement means what verbally?
Sir, the area outside A complement B. A intersection B.
This is A intersection. He doesn't want this. Except this, everything is needed. He doesn't want this. A intersection B whole complement. So it's nothing but A complement means outside. Union B complement, outside of B. That means A intersection B will not be there. Similarly, the third formula, A minus B union C. Distribution, please, distribution. A minus B, but union becomes intersection, A minus C. This may be a little difficult to understand. Let me show you through the diagram so that you'll be more comfortable. There are three sets there. What is what I'm saying? The third formula, let us understand through the Venn diagram. The third formula, let us understand through the Venn diagram. Yeah. Three circle I have taken. Yes. This is, let me say, circle C. This is, let me say, circle A. This is, let me say, circle B. Now understand the question given there. Please, all of you, understand the question given there. Question means the property. What is the property given here? A minus B union C. First of all, let me name them. A, B, C. A minus B union C. B union C means both B and C. Either B, not both B and C, either B or C or both. This entire area except this green area. This contains A minus B union C means A is subtracted from B union C. Understand that. That means only A but not B and C. Its meaning is only A but not B and C. So A minus B intersection A minus C. What is A minus B? Only A. Intersection A minus C. That is only A. I'll show you for your better understanding. I'm taking right hand side for your better understanding. I'm taking right hand side for your better understanding. That is, listen please. What is that? A minus B please. A minus B means this part here, this part. This is the part A minus B. A minus B. A minus B. A minus B is this. Come on, anyone tell me what is A minus C please. Let me show it in the vertical lines. कोई बात ही नहीं कर रहा यार. A minus C.
C doesn't come. The part of A where C doesn't come.
Yeah. A minus C means only A but not C. Only A but not C. That means it starts here. That color, let me change one moment. Ha 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 ha. Let me take black. Black, yes. Black is already used, and gray. A minus C. Yeah. This is A minus C. Intersection of these two, please. Intersection of these two, black and gray color lines intersection. It represents only A. Just check it out. Check it out. This one. Intersection of these two is nothing but this one.
Yes, sir, got it.
This is the part. This is the part. This is only A. That is the reason why these two are subtracted. That is mentioned as A minus of B union C means when you are splitting it, this union becomes intersection. A minus B intersection A minus C. Similarly, this intersection becomes union in splitting. A minus of B intersection C is equal to A minus B union A minus C. These are said to be De Morgan's laws. De Morgan's laws. Now, the next part of it, A and B are any two sets. A minus B is equal to A intersection B complement. This is no. This is very simple, yaar. A minus B complement means A minus B means only A. Only A means A intersection B complement. Means A intersection B is deleted. Similarly, B minus A can be defined. And all these are directly understood. I need not already explain you this. Similarly, this is what we have discussed already in De Morgan's laws. Okay. Niloni, if you want to take a screenshot of it, just take it, please.
Who said that?
So
Okay.
you have taken this part from the study material only, no?
Yeah, these are all there in that one. But of course, these are all mine only, but all these are included there. I verified it. Everything is there. I'll show you anyway. Next is a Cartesian product. They will be back after the break. Okay? You need break, no?
Yes, sir.
Please stay back. Don't go away. Just like TV anchor, I have to say that. And let us meet after 15 minutes. 10 to 15 minutes break, please. See you all after the break.